That worked. Wow, that was neat. Well, miracle of miracles, the Wi-Fi is back. How many of you came last month? God bless you for coming back. That's all I can say. Hopefully you all got the email, so you could follow the link to see that AJ re-recorded this presentation. I haven't had a chance to see it yet, but I hear it's really, really good. So.
You got to socialize.
Yes. So there you go. You got to socialize, you got some food, and everybody, I have to thank you all for being so gracious about that, honestly. That was awful. Anyway, so we have our speaker live in person this evening.
Right.
Anyway, so Carol, our membership director, sent an email out. Well, I guess I sent an email out.
Yes. Well,
if any of our members are interested in joining the board, we are beating the bushes looking for that. I will be actually stepping down after this year, after 11 years. We have a big move coming up into a new building, and it's just I'm gonna be wiped out of being here. I've already warned my husband to be prepared for that. So, having moved the state's collection many times, I know what's involved, and it's exhausting.
I can't really hear it.
We have one more meeting next month in June.
Have it pretty loud.
We're gonna go ahead and do a June meeting, and Big, what was her last name?
Hayes.
She was a UNF student who's now working on her master's or PhD.
Trying to see if I can make it full screen.
Keith Atkins.
So somebody's speaking here.
Oh, good. Did you see her give a presentation?
Yeah, she did well.
Okay, good. Thank you, Jeff. All right, so she's gonna be our speaker next month. So without further ado, I would like to introduce my wonderful coworker, Allisen Hunter. Allison joined us as a conservator. It's been just over a year now.
Just about.
Yeah. And so when she first joined us, the conservation office closed, and she had to work in collections, replacing bags. And she couldn't take it. They drove her crazy. But she's much more interested in conservation, fortunately for us. And that's we're very pleased that she joined us. So to give you a little background on Allison, she received her master's in classical archaeology with a specialized study in museum studies from FSU. She's a Missouri native outside Kansas City, who received her undergrad degrees at the University of Missouri Columbia, double majoring in ancient Mediterranean studies and art. She has worked at sites in Athens and Tuscany, as well as working for cultural resource management firms in the southeastern United States. So for such a young lady, I kind of pared down her bio a little bit. It's very impressive. For such a young lady, she has very impressive resume. So without further ado, I'm going to let Allison give her presentation.
Hi, thank you so much, Marie, and thank you so much for having me here. I'm really excited to share with you. As she said, my name is Allisen Hunter, and I'm excited to talk to you today about Egyptian blue. My interest in this subject began in my undergraduate program in Mizzou when I was tasked to write a paper on the wall paintings and their pigments in the Aegean Bronze Age. This was for a general introduction class on the Bronze Age. That paper was expanded into my writing sample for graduate school applications, and I delved deeper in the research from there. What I thought was just one paper in a sea of many quickly became much more. Now, some of you may be wondering why exactly I was interested in blue specifically. Everything I own is blue. Here I am studying plaster at the Florida State Excavations of Cosa, a Roman colony in Italy. And this shirt is actually blue, and the headband is blue, and the notebook is blue, and the computer is blue, and the water bottle is blue. So and the shirt today is blue on purpose. I have here in a blue car. I did drive here in a blue car. I have a little bit of a problem. So blue has been my favorite color since childhood. It's my entire life, and it has become almost comic at this point. My sister likes to joke that while my family thought that I had expanded my palette range and given up my fascination with blue with age, little did they know that I was devoting my master's thesis to the color. I am also an artist, and as Marie said, I double majored at Mizzou in studio art. The study of pigments combines both of my passions in one. It's the combination of the scientific and the artistic to better understand the world and the history around us. So, to begin, let's define a pigment. Pigments are materials that give paints, dyes, and a variety of objects in nature their color. While their final product is normally seen as a dried, ground up powder, pigments can be sourced from many organic and inorganic materials. Today, we take for granted the ease of access we have to colorful paints and dyes. In the past, obtaining consistent colors to apply to surfaces and fabric was a unique challenge of chemistry and geographic access and trade for thousands of years. The most common type.
Great, Ken. Excuse me.
No worries.
At least it was cool music.
The most common type of pigments come from the earth itself and are classed as ochres. These colors are most common in our natural world and are the easiest to source throughout time. Reds, oranges, and yellows can come from a variety of different ochres, each characterized by trace minerals. For instance, ochres with high concentrations of iron and the iron oxide mineral hematite will often produce brilliant reds, whereas those with less iron, such as the mineral goethite, will produce yellowish browns. While ochres can vary depending on the geological components of a region, their use is universal from the ancient Bronze Age Aegean to those found in the prehistoric Americas, such as these examples from the state of Florida's Division of Historical Resources. And shout out to Shara Hayes, who helped me take these pictures today. She asked for credit. Colors like white and black can be harnessed from the earth or from the burning of organic material, with pigments such as charcoal black, carbon black, bone white, lead white, or white limestone. Some colors and their pigments are much rarer to source in the natural world. These can be generated by minerals, such as the green malachite, or organisms, such as Murex purple. Of all the colors of the rainbow, blue and purple are the rarest and the hardest to procure consistent and reliable pigments for. Of the blue pigments around the world and throughout time, many are unsuitable due to their color fastness or the ability to retain color over time, their lack of sustainable production and sourcing in any given historical period, or their rarity and their chemical instability. Pigments such as riebeckite, glaucophane, azurite, and lapis lazuli suffer from these constraints. That's not to say that they did not appear or are not present in the historical palette, but their limitations are well attested in both ancient and modern scholarship. Minerals such as riebeckite and glaucophane, otherwise known as amphiboles, can be found in the soil. However, they lack a brilliancy of pigment. They are a dull gray blue in color and are relatively limited in their deposits. Azurite, a soft deep blue composed of copper, is more abundantly found, but reacts unstably when exposed to water. The color loses its vibrancy and becomes grayish and green in hue. As some frescoes are produced by suspending the pigment in water, this is a huge limitation. Additionally, its hardness requires a greater effort to grind it into the appropriate grain size to be applied as pigment. Lapis lazuli is a rich dark blue stone and is considered semi-precious and is limited in its availability and origin, coming solely from Sari Sang in Afghanistan during antiquity. Its use becomes prolific in the production of artworks in the medieval and Renaissance periods of Europe, but its use as a pigment in antiquity is limited and contested. Another explanation for this pattern could be attributed to the laborious process required to extract and refine the brilliant pigment. Instead, it produces a dullish gray result if it is produced without refinement. Humanity has often been motivated by a desire to create a stable, sustainable, readily available blue pigment to decorate its material culture with. Its rarity can give sources of the color and its depictions an elevated value. In many cultures, blue is equated to the vast sky and sea, the vitality of water, and the power of monarchs and divinities. Thus, it is no surprise that the first man-made synthetic pigment was blue. Egyptian blue is a light blue color, close to turquoise, and it is popular in the prehistoric world until the end of the Roman Empire, when production techniques were lost. The creation of the pigment is generally attested to ancient Egypt, with use perhaps as early as the first dynasty. The production technique spread from Egypt to the Near East and to the Aegean. The use of Egyptian blue in the Bronze Age Aegean will be the focus of this talk. A note on dating. You will hear me use different relative dating schemes arranged by periodization according to the material culture and settlement patterns. This is due to the fact that absolute dating at this early period is often inaccurate and leads to less clarity. I've included a chart here that illustrates some of the various dating schemes of each region in comparison to the others. And while this information is vital to my data, it is not really necessary for us to focus on in grand scale. The Aegean Bronze Age refers to the land we now know of as Greece before it was a Greece we would recognize. When many people hear the words ancient Greece, they think of it being democracy, tragedies, philosophy, the Iliad and the Odyssey, but we are looking much earlier than that. Before there was an ancient Greece, and there are many recognizable city-states, there was an Aegean Bronze Age. 3 distinct societies existed in this region, and were in contact with each other and with neighboring Near Eastern and Egyptian cultures. These were the Minoans, primarily based on the island of Crete, the Cyclades, located in the Cycladic Islands, and the Mycenaeans, based in the Greek mainland. You may be familiar with some of these names if you are familiar with Greek mythology and the works of Homer. These societies did create written records, however, examples thus far have been fragmentary, lack narrative, and are economic in nature, or are currently untranslatable. Debates persist regarding the identity of these cultures, which, if any, exerted political influence on the others, and how these factors affect the economic and material production within this area. However, it is important to note that in the late Bronze Age, it is clear from the change in material culture that a change in society, more homogeneous to the mainland, is exhibited on both Crete and the Cyclades. These cultures were the building blocks for the classical Greek world we are more culturally aware of. It is largely agreed that settlements in these cultures were organized around large administrative centers, historically referred to as palaces. I've included a plan of the palace at Pylos here. The palatial system can be thought of as a very early precursor to the city-state organization of the later Greek world. Excavations of the palaces and their metropolises have revealed a wealth of highly specialized craft production, resource storage, and monumental architecture. Wealth existed here, and this wealth allowed for a specialization in production outside of that was needed for subsistence. One of these crafts is the wall painting. Large-scale, detailed, artistically advanced, and colorful wall paintings are found in both Minoan, Cycladic, and Mycenaean settlements, and they share many similar features. These wall paintings are found in what is believed to be primarily public-facing spaces upon monumental architecture of the palace complexes. Typical iconography includes what has been interpreted as religious or political ceremonies. Here we have a possible goddess and a monkey bearing her some sort of gift. Natural landscapes, here in the monkey fresco. Snapshots of cultural activities, including gathering crocus flowers, which is where you can produce saffron comes from these crocus flowers and was considered a large export at the time. Fishing, bull leaping, boxing, nautical scenes, and battlefields. There are distinctions between the iconography present at individual societies, but a similarity in the treatment of images does exist to an extent. The first wall paintings are attested to the early Minoan period on Crete. It is again believed that the technology was transferred from Egypt to the Mediterranean, but complexities in the production demonstrate that this was not merely a wholesale copying of one culture to another. Aegean style and Egyptian style wall paintings are characterized and distinguished by their application of pigments and their preparations of the walls themselves. Egyptian wall paintings are almost entirely composed by the al secco, or the dry method of application. A surface, often mud brick in Egypt, is first plastered with lime. The plaster is left to completely dry. Preparation drawings are drawn directly upon the surface with red, black, or yellow lines, again likely ochres. Ground pigments are then mixed with an organic binding agent, often eggs. A greater range of possible pigments can be used in al secco, as the binding agent cannot dissolve the pigments. This creates a liquid paint that is applied to the dry wall. The pigment is only attached to the wall by the binder. Therefore, the deterioration of the binder leads to a total destruction of the pigment. In contrast, the alfresco method, also known as the true fresco or the wet method, originates in Crete and is seen as the primary means of application in Aegean-style frescoes. The surface, typically limestone in the Aegean, is plastered with lime. The plaster is left to dry for a period of time to stabilize, but application and preparation occurs before the plaster has completely dried out. The plaster is pressed to create a flat surface, and string line impressions or incision lines are used to plan the final work. Once the plaster is stabilized but is still damp and cold to the touch, ground pigments are mixed with water and applied to the surface. The range of pigments is limited to those that do not dissolve in water, hence the limitations with azurite. These pigments dry as the fresco dries and create a sort of crust. The pigments are bound to the wall itself, and the destruction of the painting would also destroy the finished layer of the wall. Thus, a differing conception of wall paintings is present between the methods. Al secco is applied on top of the surface. Al fresco is incorporated within the surface itself. These methods are important to distinguish as they allow for interpretations of the artist or the patron's possible identity, as this slide demonstrates, and or the political or economic connections. Iconography is also relevant to this classification and my corresponding research. My current study is limited to nautical scenes. These scenes are prolific to the region as they relate to the cultural reliance and importance on sea life for sustenance and the sea itself for trade. Trade at this time was characterized by shore hopping as opposed to open sea travel. We have evidence for extensive trade routes by sea from the Aegean nautical wall paintings, wrecks such as the Uluburun, and depictions of an Aegean trade procession in Egyptian wall paintings and administration documents. Examining the use of pigments in specific images and their manufacturing details is valuable, as the examination of these considerations can reveal new channels of understanding large-scale themes of complex economic and cultural exchange. My research concerns the use of Egyptian blue, its presence in nautical scenes, and its trace elemental compositions in Aegean-style frescoes. Egyptian blue is an artificial compound of calcium copper silicate. It is formed by grinding, mixing, heating, and then reheating sand and copper. It is nearly identical in chemical composition to the rare mineral cuprite, and it's technologically related to glass and phylons, the bright blue Egyptian objects that you often see in view. Very good. The process of making it would require training and technique to ensure a consistent, desirable product. There has been interest in recreating the recipe for the pigment since the early 19th century, but only recent research has focused on the individual chemical elements of the pigment's makeup and those elemental implications. Elemental components can be revealed through a variety of chemical and elemental analyses, such as XRF, X-ray diffraction, XRD, laser-induced breakdown spectroscopy, LIBS, mass spectrometry, scanning electron microscopy, SEM, and Raman spectroscopy, to name only a few. Given the production factors we have reviewed thus far, a few patterns and examples of interest become present. On the screen, you can see where all the different sites that I am looking at that exhibit Aegean-style frescoes based on the definitions we have discussed this far. While Egyptian blue is the most popular pigment present in the Bronze Age Aegean, it is not the only option. Amphiboles, such as riebeckite and glaucophane, that we discussed earlier, are found mixed with Egyptian blue in many frescoes, dating before LM1A, especially on Crete and in the Cyclades. The inclusions of these other pigments could be motivated economically as an effort to conserve a limited amount of Egyptian blue in early context. However, the uses of amphiboles could indicate separate schools/workshops of production and technique. Examples from the Cyclades demonstrate pigment choices may be based on a desire to represent nature or iconographic rules of depiction. The natural grayish color of amphipoles is utilized in several sea scenes to distinguish the color of water closer to the shore. Right here. Versus that of open water. This implies that the choice of applying which pigment where cannot be solely explained by economic motivations. Rather, individual cultural traditions and artistic definitions persisted. The use of Egyptian blue as the primary blue pigment takes off exponentially after LN1A. Whole background planes are colored by the pigment and demonstrate both a wider availability of the pigment and a change in iconographic preference. Sea scenes of the standard white line sea floor background are entirely replaced by large planes of Egyptian blue. The change in material and conception of suitability is exemplified by an unusual scene in Pylos, a mainland palace, where large background planes have been painted purple. Egyptian blue is mixed with Murex purple to create the hue. This color is both a departure from the more naturalistic efforts found in the Cyclades and from the blue plains of Crete and other mainland sites. To make matters more unusual, the pigments are applied in Alseca. These features are distinct and may indicate an effort by Knossos to demonstrate its power and prestige in comparison and in competition with other palaces. Additionally, the source of copper in the production of Egyptian blue and its related elements, such as tin and arsenic, have implications for the source of the production of Egyptian blue. The presence of tin within Aegean concentrations of Egyptian blue has been examined by Anne Bursberg and continues to be a promising field of study for a locally manufactured pigment. The use of tin is not found in Egyptian blues used in Egypt before the 18th dynasty. Where data is available, a significant number of Aegean-style frescoes contain tin in their Egyptian blue. These all date to before this chronological mark. Other Aegean-style frescoes may also contain tin, but the data is either unclear or unavailable at this time. Thus, the inclusion of tin at an early period of Egyptian blue use contributes to a theory of extended experimentation. The presence of tin, a key ingredient in bronze production, indicates that a recycling of bronze is occurring in order to harvest the copper needed to create Egyptian blue. The introduction of tin in Egyptian blue may indicate a transition from the importation of Egyptian blue from Egypt to a local production within the Aegean. A lack of tin in Near Eastern sites may indicate a local tradition of resource use independent from the Aegean. This is especially prevalent as there are Egyptian garrison sites in Egypt, so there are sites in the Near East that are under Egyptian rule, and perhaps the Egyptians are therefore exerting power in order to have their trade routes and their manufactured goods be the primary method of application. The influence of local tradition in the Near East is further demonstrated by a trend of combining both al fresco and al secco application techniques. This is unique, as we do not see this except in Pylos. More studies regarding the elemental composition of Near Eastern wall paintings are needed before these theories can be confirmed, but they are promising avenues of future research. A similar set of circumstances are present when arsenic is measured in Egyptian blue. The appearance of arsenic can be explained by the reuse of arsenical bronze, an early chronological marker of bronze production. Studies are limited, but as of yet, arsenical bronze in Egyptian blue has only been present in later Mycenaean wall paintings, perhaps further supporting the material culture shift observed in other crafts after LM1A. Groups such as the European Research Council Starting Grant funded, HUE, Color and New Light, Origins, Trade, and Cultural Significance of Ancient Pigments, are actively exploring these exciting avenues, and I look forward to their publication. These examples are brief descriptions of my conclusions and possible avenues for continued research. However, they illustrate the value of studying Egyptian blue and its use, production, and technology transfer. Studying Egyptian blue not only allows us to deconstruct the artistic choices of artisans, but also has the potential to reveal complex borrowing of traditions between cultures, demonstrations of local identity in schools of production, and economic pathways of material trade and production. As introduced at the start of the presentation, blue is a highly sought-after color throughout history. The production and trade of blue pigmented materials and their sources have long been valued and at times exploited by different powerful structures to harness that prestige for themselves. While my research is focused in the ancient Mediterranean, these technical studies, and particularly the study of pigments, have value throughout time and space. To illustrate this, we will briefly turn to the Americas. Similar chemical trace studies have been conducted on turquoise found in the greater American Southwest and Mesoamerican continent. The rarity of the color, the limitation of turquoise deposits, and the assigned prestige of exotic items produced from long-distance trade routes resulted in a highly valued commodity. Excuse me. These long-distance trade networks are similarly informative to the economic relationships between cultures, similar to that we have seen in the Aegean Bronze Age. Examining trace components and chemical backgrounds allow for more complex relationships to be revealed, despite culture or time period. Another blue pigment valued in the Americas comes from the indigo plant. While indigo has a long history with use beginning in ancient times, its cultivation in the 1700s in the Americas was motivated by an effort to produce more cash crops for the British Empire. Beginning in South Carolina, indigo was planted along the southeastern coastal colonies and sent back to Britain for sale. The planting, harvesting, and refining of the plant into a dye product to be sold to the textile industry was accomplished through enslaved labor. This period of indigo production, losing its popularity after the American Revolution and the subsequent weakened trade routes with Britain, is argued to correlate with an increased expansion of slavery in the colonies due to the economic demand for the prestigious dye. However, recent research suggests that there is actually a complex relationship between the enslaved Africans who produced the plant and dye and its symbolism. The necessary skilled labor required to produce the pigment may have created more positive associations with indigo than with other cash crops. This association, in combination with existing West African cultural and spiritual practices, has led to the value of blue by the Gullah Geechee peoples of the American Sea Islands. The blue bottle tree and ink blue architectural features both assist in the warding and capturing of spirits and relate to the West African afterlife beliefs. Indigo is attributed as the source colorant of the original historical pink blue paint. The complex relationship between the enslaved, colonial powers, the economic production of this blue pigment, and their possible symbolic usage stand as an example for the profound connections to the color blue and how it can be used. Whether it's the use of lapis lazuli in medieval European paintings to note the clothing of the Virgin Mary, the search for a stable synthetic replacement in the creation of ultramarine, the trade of turquoise and turquoise-based goods in the American Southwest, the cultural importance of ink blue to the African diaspora, the exploitation of land and people by the British to harvest vast amounts of indigo in their American colonies, or the unknown symbolic meaning but clear cultural value present in the widespread and varied use of Egyptian blue in the Bronze Age Aegean, blue colors are. Thank you.
That's it.
I now welcome any questions.
Couple of questions, you mentioned that when the Egyptians were producing, at least I think this way, said that when the Egyptians were producing this, that sometimes they would get bronze things would they try to, I mean, I assume that they had to extract the tin from the bronze though, right? Or is that even possible?
That's a great question. So in Egypt, tin doesn't show up till much later in any Egyptian blue test that we do on them. In the Aegean, tin shows up pretty early. And what that tells us is that they are recycling bronze and the copper in bronze in order to create Egyptian blue. You don't have to separate the component parts. You're just able to throw it all together and it still creates Egyptian blue. So yes, so this is a trace chemical that we're studying, and that's why this is sort of new research, because as our testing equipment gets better, the more we're able to pick up on these tiny little portions that actually tell us a great deal about where things come from.
This, and one other thing, this is kind of off the wall, but have you ever crossed paths with Allisen Hunter by any chance?
I don't believe I do. I have.
She's at Carleton College, but she's really focused on studying the chemical composition of turquoises now in the Southwest. I don't know if you maybe cross paths.
I hadn't, but that's fantastic. That's partially why I included turquoise in this presentation, is I do believe there is quite a bit of value in looking at this pigment, this color that throughout time and space we've really tried to find and control in different ways. No matter where it is, tracing those elemental components gives us a better idea of where things are coming from and how we can take something very small and expand it out in dramatic ways.
Do we know if when you use bronze and it ends up like mixing with tin or was it arsenic was the other one?
Yeah.
Does that like cut the color at all? Does it make it less vibrant or less able to adhere, or is it like so traced that it doesn't really affect it at all?
So there are actually people doing those exact studies. It has been this is very recent research. And some people have started to look and see about this. I believe actually in 2024 was the first time I had seen, and according to these scholars, this was the first time a study of that subject had been produced, where they were actually looking at different percentages and components and seeing what sort of colors that produced and trying to see if there was a difference. Would people be able to tell? Could there be, a reason for trying to make things outside of just the tin is there anyways? So it's a really good question, and people are trying to explore that now.
Have you looked at lion blue pigment?
So I'm aware of it. I have not studied it in a great deal, but it is another sort of interesting effort to create a pigment that, we have the sky, we have the sea, and we kind of just assume blue is all around us. But if you look at nature, there's very few blue flowers, there's very few blue fruits, there's very few blue anything. So I have heard that the line is trying to create their own synthetic.
It was believed by some people that it's a clay-based mineral out of Allisen, and it's mined just a few miles away from here, as
Interesting.
well as in Central America.
That's very fascinating.
Yeah.
I've seen some presentations.
You like new pigments, so just make sure that.
I'll have to check it out for sure. I think I saw a hand.
Dean Arnold has done a bunch of stuff on that Maya blue stuff, and I think that they actually made some real leaps forward fairly recently. Though I didn't read them actually, but I remember seeing something about that. So the literature may be out there.
That's fantastic. I was looking up to see one presentation on that at a previous conference. I'll have to check it out more.
The when this was much of this being traded around, or were they pretty jealous about keeping it like, it's called Egyptian blue, but we know just the Egyptians weren't making it or whatever, but I mean, was there a brisk trade in it, or were they really keeping it in their own area?
So our question is more about who has the recipe and who can make it, but the trade is established. The Uluburun wreck is actually a shipwreck that is in the Mediterranean. It's off the coast of Turkey, I believe. I invite anyone to correct me if I am incorrect on that. My area is Greece. So this shipwreck is actually a Bronze Age shipwreck. It's one of the few that survived based on some of the conditions, and they found pigment lumps. So there are ingots of pigment, and at different sites, some of these sites that I discussed, I wasn't able to go into much detail, but there's not just Egyptian blue on the walls, but they have found in excavations lumps of the pigment. So they believe, based off of how the cake is shaped, and you can see one of the cakes right here. If you have it in a block, it's one culture. If you have it in a disc, it's another. And I can't remember that off the top of my head, so I don't want to give you an attribution that's incorrect, but this is another one of those factors of, if we look at how things are made, we can actually sort of find out maybe where it came from. And we can figure out those sort of grand trade networks that are occurring. So we know the technology was traded, and we know the recipe essentially was traded, as well as the objects themselves. So
I'm not trying to monopolize stuff, but I worked in Jordan some years ago, and one of the things that we found it really surprised us was a rock. I mean, it almost looked like a sphere of rock, but it turned out it was in half. And when we opened it up, there were these little, it turned out to be what we think was a woman's makeup.
Oh, yeah.
And there were blue pigments in there.
Mhm.
I think that could have been the same basic elements that we're talking about here, or would they be something that would stay on your skin, in other words, or on even on your eyelids if you put them on there? I mean, you're not gonna have to moisten them, I guess, but.
So that is a fantastic question, and we actually know that what they would mainly use was that pigment they were talking about, azurite, which is not great in Eugene wall paintings because if you try and put it on the wall, you necessarily have to get it wet. And in doing so, that brilliant dark blue becomes rather greenish and sickly colored. But the nice thing is on your face, it doesn't look sickly. They actually would use, it is attested in Egypt that they use both malachite, which is the green that we looked at, and azurite, which they actually come from the same copper mineral. They're both copper denigration processes. So as copper deteriorates, as we know, it gets that kind of lovely blue green patina. And different minerals can actually crystallize like we looked at. So that's what azurite and malachite come from. And they were actually ground down and produced as eyeshadow. And it was believed that was both symbolic and, you know, just a nice pretty making device. So symbolically, it would maybe help ward away bad spirits, the evil eye, and maybe perhaps protect your eyes from the sun.
Hopefully in place of something like beeswax.
Yes, exactly. Beeswax, and then I believe there's a couple like animal fat kind of products they would use. I can't remember off the top of my head, but they would use some sort of organic animal fat, and that would kind of help stick it to it.
I was just gonna comment that, it's very interesting about the connection with the African slaves harvesting indigo for,
South
British.
Carolina. All of
Examples you showed are actually much earlier, probably than you realize, they're from the Spanish plate wrecks.
Excellent.
So either 1715 or 1733. So they would have learned about that from
Yes.
from the natives.
The indigo, and indigo is not my area of specialty, but I did a little research on it, and it appears that the harvesting of indigo was by no means a British venture alone. There have been many cultures throughout time. I referenced vaguely, we do see occasionally in the Near East, possibly in the ancient Near East, they are using indigo as a pigment on their wall paintings. However, it's organic material, so it's destroyed very easily, and it's applied by organic material with eggs, so it's destroyed very easily, and we're only just starting to get instruments that are able to pick up that tiny little portions of things that survive. So indigo has been there was exploitation of it by the Spanish, there's exploitation of it by the British, it's also the indigo that was planted here is not actually native to here. I believe it was the Indian indigo that it was just better, it thrived much better in the environment. So indigo's use has been throughout time and place, and that's why I decided to include a section. I did not know it was from the plate, but it is an excellent example of showing how long we have been looking at these pigments and how much we've been obsessed with the color.
Wow. Hey, my goodness. And she sings.
I
plays guitar.
Incredible. What a great job, Allison. Minute now. So your award for going through all this is that you get a grant. Thank you.
Thank you, Marie.
We can use.
All right, everybody, we have another question. Oh, sorry.
No, you sing the blues.
I do.
You can trade it in for a t-shirt. We do have t-shirts, good point. Yeah, this one's green.
My father would have been very upset if I didn't sing with Lewis. So that is in my repertoire. Ray Charles is there.
Hey.